Good morning, everyone. We are going to continue with our chapter number second, Introduction to UML. In yesterday's session, we have seen some introductory part about UML. That is, what is UML, why we use UML, some types of UML diagrams, some examples. Okay. So in yesterday's session, we have seen what is UML. That is Unified Modeling Language. It's from OMG standard. That is Object Management Group. Okay. There are some researchers who contributed for that based on work from Booch, Rambach, Jacobson. Okay, it's a modeling language to express and design documents for software. Okay, particularly it is useful for object-oriented design. Yesterday we have seen that it is not a process. Okay, it is not a process, but some have been proposed using UML. We are going to use UML for diagrams. Okay, it is for software development. Okay, then yesterday we have also seen why we use UML. It is an open standard or graphical notations for specifying, visualizing, constructing and documenting software system. To document the softwares, we are using UML. Okay, it's a language. It can be used from general initial design to very specific detailed design across the entire software development lifecycle. In SDLC, there are several stages for software development. For every stages, we are going to draw the diagrams for that software. Okay, we have seen that why we use UML to document that software. We are going to use that UML diagrams. Then next topic is history about UML. Okay, this methodology started in early 90s. Okay, there are some researchers who are invented this system. Researchers like Booch, Jacobson, Yarden, and Rambach. In 1994, Booch and Jacobson merged some methods in that methodology. In 1995, Rambach joined that object management group. Okay, in 1997, UML 1.1 object management includes input from some other researchers like Yarden. Then currently we are using UML version 2.0. Currently we are using 2.0 version of UML. Here you can see the history of UML. First, in 1995, it's a unified method point 0.8. It includes the Booch object-oriented analysis and design and OMT. Okay, in 1995, it's a unified method. Then in 1996, it's a UML 0.9 upgraded. Some other methods are included in UML 0.9 for object-oriented, like object-oriented software engineering. Then some URL patterns are involved in UML 1.0. Okay, in that first it submitted to object management group in January 1997. Then there is final submission to object management group, that is OMG, in September 1997. Then these patterns or the submissions are accepted in November 1997, that is UML 1.1. In 1.0 some UML patterns are there. Then these patterns are going to be standardized and it is accepted in 1997 in UML 1.1. Then this version is revised in UML 1.3. Then you can see the history of, then the next version is UML 1.4. Then currently we are using, the version is 1. Current version is 1 UML 2.0. This is the history about UML, Unified Modeling Language. Okay. Then here you can see the contributors to UML. These are some researchers who have contributed for UMLs. Okay, Jacobson, Object Management Group, Analysis and Design Group, Booch, Mayer, Harris, Richards, Gamma. Okay, these are some researchers or some industries who have contributed in Unified Modeling Language. The next topic is systems, models, and views. Okay, what is system, what is models, and what is views? A model is an abstraction describing a subset of a system. Whenever we are going to consider a system for, or we are designing a system, then we have to design a model for that system. By using this model, we can describe our system. Okay, this model is abstraction of our system. The next one is view. View depicts selected aspect of model. We are going to design some views for that model. Okay, then a notation. Notation is a set of graphical or textual rules for depicting views. There are some notations for depicting that graphical or for that views. Okay, views and models of a single system may overlap each other. Consider example of aircraft system. We are going to develop or design aircraft system. For that, there are some models. Okay, like flight simulators, scale model. Okay, then views. Views means there are some blueprints for that system, some electrical wiring, fuel system. These are the views for that system. Okay, so see the example. Here you can see the system, aircraft as a system. Then there are some views. Okay, views like blueprints, then electrical wiring, and there is a model like scale model and flight simulator. This is a system. Then it consists of models and views. Okay, here you can see the diagram for that models and views. UML is a multi-diagrammatic language. UML is a multi-diagrammatic language. In this, each diagram is a view into a model. Each diagram is having some views. Okay, these diagrams are presented from the aspect of particular stakeholder. Then it provides a partial representation of the system. Okay, here consider the example for views. Here consider the use case views. There are four views: logical view, implementation view, process view, and deployment view. In logical view, end user is there. Whenever we are going to design any system, first we have to gather the requirement from the user. Based on that requirements are the functional requirements. Based on the requirements, we are going to design or implement a system. Okay, so that is logical view from end user. It includes the functionality of system. The next view is implementation. In implementation view, programmers are there. That is software management team. We are going to implement or we are going to program that requirements from logical view. We are going to implement the system. That is implementation view. The next one is process view. In process view, system integrators are there. Okay, that means we are going to measure the performance, scalability, and throughput of the system. That is process view for the system. Okay, and last view is deployment view. In deployment view, we are going to engineer. That is, we are going to deploy the system to the end user, and we are going to install or communicate the system over the network. If it is in network. Okay, that is, there are four views under use case view. For use case diagrams, for use case view, there are four views for system. Okay, then here you can see the models means there are two views, dynamic and static. Okay, in models there are several diagrams. We are going to design diagrams for the system like use case diagram, sequence diagram, state chart diagram, collaboration diagram, activity diagram. Some statical views like class diagrams. These are fixed. Okay, class diagrams, you cannot change the classes, objects, and components of the system. Okay, and deployment diagrams. These are the diagrams for models. These are the models. Okay, then there are some basic modeling steps. First one is use cases. In use cases, we are going to capture the requirements from the user. Then domain model. In this, we are going to capture the processes and key classes. Okay, we are going to capture the processes, that what a system is going to do, and the key classes. Okay, then design the model. In this, we are going to capture the details and behaviors of use cases and domain objects, how system is going to behave. Then okay, we are going to capture the details of that system from use cases. Then we are going to add the classes that do the work and define the architecture. In design model step, we have to add the classes and we have to define the architecture for the system. These are some modeling steps for diagrams. Here you can see the UML baseline. In yesterday's session, we have seen the types of diagrams and some examples. Okay, then here you can see the use case diagram. Here you can see the actor, passenger. Passenger is the actor, and you can see the ellipse. This is the use case. Okay. So what actor it is? Actors represents roles. That is type of user of system. Actor is the user of the system. User may be any entity, any person. Okay. Then use cases represent a sequence of interaction. It represents the sequence of interaction for a type of functionality. Okay, it's a scenario of your system. Here you can see the actor and use case. Here actors. Okay, an actor models an external entity which communicates with the system. Actor can be user, external system, or physical environment who can interact with the system. Okay, an actor has a unique name and an optional description. Okay, actor having some names. Okay, actor can be, it may be a user or external system or a physical environment who is going to interact with the system or who is going to communicate with that system. Okay, here you can see the example of actor. Like here actor is passenger. Passenger is in the a person in the train. Okay, then use cases. Here you can see the use cases as purchase ticket. A use case represent a class of functionality provided by the system as an event flow. Okay, here use case can be, it consists of unique name, participating actors, entry conditions, flow of events, exit conditions, or some special requirements. A use case consists of, you can give the name to use cases like, can be a participating actors, entry condition, exit conditions, flow of events. Okay, some requirements. These are your use cases for that system. This is the use case. Consider example for purchasing ticket. Okay, purchasing ticket, participating actor is passenger. Okay, then entry conditions, these are the use cases. Passenger is going to stand, passenger is standing in front of ticket distributor. This is the entry condition, and passenger has sufficient money to purchase the ticket. Okay, passenger has to purchase the ticket. This is our use case diagram. Then this is the entry condition, and what is the exit condition? Passenger has ticket. Then what are the event flow? Okay, these are the event flow use cases. Passenger selects the number of zones to be travel. Then it distributor displays the due amount. Then passenger insert money at least the due amount. Then distributor returns the change, and distributor issues ticket to passenger. Okay, this is the simple use case diagram. Okay, here you can see the relationship in use cases extends. Okay, here you can see the passenger, this is the actor. Passenger has to purchase the ticket. This is the use case, and this use case, there are several use cases under there: out of order, cancel, no change, timeout. These use cases are sorry these use cases are extended from purchase ticket use cases. That is, purchase ticket includes out of order, the ticket may be out of order, it may be cancel, or no change, or timeout. Okay, these are the relationships. This is the extend relationship. It represent exceptional invoke classes. Okay, exceptional event flows. This is the relationship for use case diagram. Then next relationship is includes. First one is extend, the next one is includes. Here you can see the passenger is purchasing ticket, or it purchasing a single ticket, or it purchase multiple tickets. Okay, both includes, both have to pay the money. Okay, so here you can includes both use cases combine in one use case like collect money. Okay, here you can see the include relationship. Include relationship represents behavior that is factor out of the use cases. Okay, behavior is factor out for reuse, not because it is an exception. Okay, you can reuse the use cases here. Okay, collect money, this is extend relationship. Okay, collect money, you can, there is no change or cancel amount. Then use cases are useful to determine the requirements, then communicating with clients, generating test cases. Okay, these are the advantages, or you can say these are the uses of use cases. Through use case diagrams, we are going to determine the requirements, we are going to communicate with clients, generating some test cases for the diagrams. The next one is class diagram. In yesterday's session, we have seen the class diagram. What is class diagram? Okay, so here you can see Here you can see the example of class diagram. A class represent a concept. Here you can see the class diagram. As we have seen that class first letter should be capital O or upper letter. Okay, this is the class name, then attributes, then operations. Okay, a class encapsulates states. States means attributes and behavior means operations. Okay, here you can see the class name as tariff schedule, then attributes zone to price. Then these are the operations. Each attribute has a type, that is data type. Okay, then each operation, that is each operation means each method is having signature. Okay, the class name is the only mandatory information. Class name is always, it should be available. Okay, this is about classes. Then instances means object. Here you can see a instance represent a phenomenon. The name of an instance is underlined and can be contain the classes of the instance. Here you can see the class name is tariff schedule. Then here you can see the tariff 1974. This is the object or this is the instance of that class. Okay, this is the syntax how you can draw the object diagram or instances. Here these are the attributes that are represented with their values. These are the instances. Then we have seen the class notations. Here you can see the example of class. Here this is the class name, employee. Class name, first letter will be initial letter as a upper letter or capital letter, that is employee is the class name. Here you can see the modifiers, private indicated by minus sign, that is dash. Or whenever we are going to declare any attribute as a private, I already told you that you cannot access outside the class. Then plus is for public and hash is for protected. Okay, here you can see the example of class name. These are the attributes and these are the functions or operations. Okay, there are some relationship for classes. First one is association, then aggregation, composition and inheritance. Okay, here you can see the binary association between classes. Here binary association means both entities know about each other. Here these are the two classes. Whenever we are going to assign, or this the, you can see the line, this both classes are connected to each other by line. That means binary association means both classes know about each other. This is the binary association. Okay, then unary association, that means A knows, here you can see the class A and class B. A knows about B but B don't know about A. This is the unary operation, one way. Okay, here this arrow points in direction of the dependence. A is dependent on B. Okay, here you can see the operations. This is the unary associations. Then aggregation, see the syntax. Aggregation is an association with the collection member relationship. Okay, this is the hollow diamond on the collection side. Okay, you can see the class create and module. Okay, you can see the association, aggregation. Okay, these are the relationship for classes. Then next one is composition, field diamond. Okay, composition is aggregation with, okay, lifetime control. Owner controls construction, destructions. Okay, here you can see the, consider, here you can see the team. Class name as a team and there are some members. This is the object of class employee. You can see the employee class. Okay, this is the composition. That means it, this relationship includes, this class includes this. Okay, you can say this is the super class, it includes the another class. Okay, this is the field diamond on the side of collection. This is the collection class. Okay, it includes the employee. Okay, it includes the employee class. This is the way you can give the relationship for that classes. This is the composition. The next one is inheritance. Here you can see the base class and derived class. Okay, this is the class name, attributes and operations. How the class is inherited, you can see the arrow. Okay, here class B extend class A. This is the concept of inheritance. Then multiplicities, 0 to 1, 0 to many, or exactly 1 or 1 to many. Here you can see 0 to 1, 0 or 1 instance. Here you can see 0 to star, or there is no limit for instances. Okay, here exactly 1. If you are going to mention 1 as a multiplicity, then that means exactly 1 instance. Here 1 to many, that means at least 1 instance should be present. Then this is the example. Here you can see the customer class having attributes name and address. Okay, then another class is order class. Here you can see the relationship or multiplicity, one to many. Okay, these are the associations. Here you can see the associations. Okay, this is the generalization. Here you can see the payment class. Payment class is generalized. There are three classes. Okay, credit by credit, payment by cash, or payment by check. This is the generalization. Okay, this is composition. Okay, aggregation, one to one. Okay, order and order details for that order. Okay, these are the classes and attributes and operations. You can see here this is the multiplicity. Okay, one to many, zero to many, or exactly one. Okay, these are the class name, these are the attributes, and these are the operations. Okay, this is the example for class diagram. Okay, then next we have seen the object diagram also. This is the example. Format is instance name, that is, here you can see the object name m1, and this is the class name. Okay, object name colon and class name, it should be underlined. This is the syntax, that is id label, that is object name, then class name, and then attributes with their values. This is the object diagram. Okay, then yesterday's session we have seen the package diagrams. Okay, here you can see the example of package diagram. In package diagram we are going to combine the complex classes into a packages. Okay, you have learned already, you have learned, I think, that you can combine the several classes into one package. Okay, here you can see the multiple packages. The packages are include the several classes. Here this is the syntaxes, or this is the way how you can draw the packages. Here you can see the packages. Okay, student package, it includes academic employees, mailing list. Okay, this is the example of package diagram. Then interaction diagram include the sequence diagram. Here you can see the actor from use cases. Okay, this is the actor, these are the objects in your system, and these are the activation bar. Okay, this is, you can also call this as the lifeline. Okay, that solid line is called as calls, and the dashed line is written. These are the calls to system, calls to object, or these are the return message from that object. Okay, here you can see the message like from actor, like enter item number to process order screen. Then it will be second message is from the first object to second object, that is find the item, then get the quantity, and then return message from that process like display the details. This is the sequence of that diagram. Okay, these are the sequence diagram. Then we have also seen the collaboration diagram. Okay, it is like say, you can say it is similar to sequence diagram, but only it is, see the difference between that, there it's only a vertical sequences. Okay, you can see the collaboration diagram. Then study session we have also seen the activity diagram. Here you can see the flow chart. Okay, this is the rounded ellipse for rounded rectangle for the flow. This is the conditional box, this is the start, this is the end of the flow chart. Okay, in this way you can draw the activity diagram. Here you can see the example of activity diagram. Customer, here start the system, this for ATM machine. Okay, insert the card, enter the pin, after that authorize that pin. If it is valid, then move forward. If it is invalid, then end or eject the card. Okay, this is the fork, this is the join. Okay, then we have seen the state transition diagrams. Okay, we have seen the component diagram. This is the way we can draw the component. Okay, components are shown as a rectangles with two tabs at the upper left corner. Okay, then we have seen the deployment diagrams. Okay, thank you.